All right, so we're recording now. I've graded your exams, I believe, so check on that, make sure everything's good. I think I've graded like two of your assignments or three of them. So kind of on track. I'll be grading another one sort of this week. Look at those. As I said, it's week 8, so this is the middle of the semester. No midterms, obviously, because I do exam 1, exam 2. So the next exam will be on week 12. All right, so that's at least the advantage. So a lot of people are having midterms probably this week. Spring break is coming up in about 2 weeks, so just be aware of that. Yeah, and so last week we were doing the firewalls lab, right? And today we'll probably look at the netcat part and a few things if you guys are still behind on something, but you could advance. I did eventually fix my problem with the VMs. I had to literally just give the IP manually and it works. So somehow on my machine it wasn't getting the IP. I'll show you what I did, but at least it worked after many hours of debugging it on Sunday. But yeah, so we'll discuss that. So this puts us ready, I would hope, for one of the hardest labs, one of the two hardest labs in this course, right? You know, you've had about 8 weeks now of Linux. So this one is going to be a little bit more challenging, more abstract. You're going to need two virtual machines. So I'll go over it. It's DNS, right? So we're going to go over DNS, and the goal with this lab is that you'll have two VMs, a DNS client and a DNS server. So I'll talk about what DNS is, but you guys know what that is already because you've taken a lot of networking courses. So this just is in the focus is mainly on Linux commands, sysadmin configuration, that type of thing. That's not the most challenging. The most challenging lab is the Hadoop lab, and that would be the next one. All right. This one is fun though because it has attacks and cybersecurity embedded into it, so it should be a fun one, and I'll walk you through. I'll show you a new tool for doing attacks. Very powerful network attacking tool. Obviously, don't attack networks with it, but we will use it in the course. Are there any questions? Yes, sir, please. Oh, really? Yeah, I think I was having so many problems with that I am. I'll do that now. So you completed the whole thing? All right, good. All right. So yeah, that's good. So that's a good point. Let's go ahead and go over that one. All right, so we are in table of contents here. All right, so let's look at table of contents. This one over here. So we've done all of this, account management, host-based firewalls. As you can see, today we're starting DNS. I have several slides for that. If you look, I have Hadoop, SNMP is actually pretty easy, I would argue. And then just some miscellaneous topics related to Linux and things like that. And your Wireshark readings, I've been putting those off, but I will start assigning those. They're very easy and straightforward. So let's create the homework link. So it's going to be here. So I'm going to do new assignment. All right, so this is going to be homework, firewall. It's going to be due, this was the 27th, so it would actually be due on the 6th, 10 p.m. It opens up. Yeah, 6. And it'll stay open until, let's say, so complete the problems on the attached Word document. All right, so that should be enough. All right, so that's been created. So now we are ready to move on to the table of contents again. And we're going to take a look at DNS. Domain name system. So I have two sets of slides here. I'm going to start with the one that's my notes. That's going to be the more specific one to the lab. And then I have this other one, which is more PowerPointy. And that one has many commands and things like that. So we'll just talk about it. DNS is a huge topic, actually. So definitely read through these, okay? My recommendation, always read through all the documents I provide, but just look at the Word document as to what I want you to do. There's also a PDF, actually. And this PDF, I strongly recommend that you guys read through it. Very interesting. A lot of information, commands, graphics. So also very helpful for what we're going to be doing. This actually, I believe, it has a tutorial on configuring bind9. So that's actually the service that you're going to configure. So the way that this lab is going to work is that you're going to configure the service first on Linux, test it to make sure it works, and then to get a better understanding of how DNS works, we're going to do some attacks essentially, and that way get a feel for the way it works. You've already done the SCAPI lab, so you have familiarity with packets and things like that. So this should be consistent with that approach. All right, so let's start with the slide. So these are my notes, kind of what I feel is like a summarize, and then sequence. And it should be, actually, this is the other one. I need to download it probably. This one for the slides. All right, so these are my notes on today's lab. So DNS. So I'll give you just a brief reminder of what it is in the notes. Then we're going to start looking at what we want to do and some of the commands essentially, and I'll boot up the virtual machine to illustrate. So DNS, managing network services. Essentially, you know that computers work with IPs. We have two computers. Each one has an IP. And so DNS resolves names to IPs, as you guys know, essentially, right? So you have hamlet.com and it gets converted into some IP address. That's it, right? And then we just have the reverse of that, right? But essentially that's all it is. So it's more convenient, as you know, to use names. The networking abilities, translating a host name to an IP, okay? And then number two, determining the route of a desired remote destination, right? So it's all about you want to reach somewhere and we need a system of doing that. So DNS stands for Domain Name System. It's a facility that provides name resolution services. Of course, in Unix, we have our own service, and that's what I'm going to focus on. It's called, in Unix, this is known as bind9, right? Bind stands for the Berkeley Internet Name Domain. You can see the name reference is to Berkeley University. So a lot of these things on the internet, especially, started at universities. Well, you guys have seen even system administration started at universities. All right. So I believe the year is like 1984 when this happened, when you had the DARPA project and everything, and they were creating these systems. So that's bind9, and we will install bind9 on our Linux Ubuntu machine, and then essentially have to configure it, okay? This is going to be important. You have already a DNS server, right? Because your automatic configuration of your VM essentially downloads a DNS server from the university. They're going to be like 205 something or other, but we're going to have to replace those with Bind 9. So there's going to be, that's why this lab involves two virtual machines, one which will be the DNS client, and that one that's going to be the DNS server. So we are going to essentially create our own. And so you have to learn that whole process. Now, the documentation is really good, I should say. You just have to read it very carefully, but it's almost like a tutorial that you can follow. And it'll be like your very first actual configuration of a sophisticated service on Linux. Bind 9 is usually a good one to start with, as it is pretty straightforward. At the end of the semester, you guys can do presentations on a project, and your project is something like this. We can't configure all the services, right, for Linux. So, but students in the past have done an email server, a VPN server, some other service configured in Linux. That's the whole point. So look at this example as a kind of a template of what your project might be at the end of the semester. Does that make sense? Yeah. Start thinking about that, actually, given that we are on week 8. So, start thinking of yes. Pardon? For the project, you don't need to use Docker, but you could use Docker if you want to take it beyond. I will, it's one of the lectures where I will talk about Docker and how it works in the future. And if you want to do a project that uses it, as long as it's using Linux, yeah, there's nothing wrong with it. But no, it can just be like this lab does not use Docker. You're just setting up one Linux VM to be a DNS server, and then you'll have another machine that interacts with it. Got it? All right. So like I said, so we have bind. So bind 9 has essentially two distinct activities. A, the actual host name to IP address translation. So that's going to be when you get a host name and you want to find the IP for that. Now that assumes that that information is on those DNS servers, right? So that's essential. So remember that there isn't one centralized database of DNS servers. Instead, these are distributed. Like every organization will have their own little, information, right? And if that and there's some centralized called root DNS servers as well that coordinate everything, right? So that's kind of the idea. And if you don't have the information, then the servers also need to have the activities for B, which is the distribution mechanisms for the underlying translation data. So distribution, how do you get the information from someone else, send it to someone else, or query someone else? Okay. So structurally, DNS is a distributed database whose contents are spread across the entire internet with individual DNS servers permanently storing only a subset of data for which they are responsible. Okay, so that's essentially the idea. So you guys will create, a domain example.com. That's going to be your domain. And then you're going to have your own servers in there. Remember, you're going to have your email server, your WW server, your whatever other server. What would it be? Mail, a DNS server, essentially. And if somebody wants to reach you and send you email, you would be able to provide the translation. Okay? So that's yeah, go ahead. It's the world. That's planet Earth. Sorry, that's my rendering of planet Earth. Pardon? I have another set of slides that has actual proper pictures. These are just my notes to summarize today. But you can look at it, look at the other ones. We'll look at the other set of slides in a minute. All right. So yeah. So basically you have queries into this massively distributed database work because DNS has the ability to forward translation requests to the appropriate servers automatically. That's essentially the key, right? So if somebody makes a query to you and you don't have it, then you can send it to your next contact, if you will, and saying, who is this? Because I don't know who it is. And that's the idea. So that's why you have server A here, right? And it's saying who is to their DNS server B. But if B does not know, it can essentially send a request to C. And then when it gets a response from C, it's going to store it in its DNS cache so that the next time that the request comes in, it retrieves it from there. Does that make sense? And what's important about one of the things that we will do in the lab is that we're going to make attacks to these things so that we can get a better understanding of how it works. Okay? But essentially that is A could be the DNS client, B is the DNS server. It says who is this via a packet, and then DNS does not know, so it sends to C, C replies, and the information is stored in the DNS cache, essentially. Okay. So domain names, the DNS organized structure defines the domain system, the domain name hierarchy. Domain names are arranged within a tree structure rooted at the root domain. So essentially everything kind of starts from the back to the front. It's just kind of interesting. Like for many years, I just knew www.amazon.com, and I never quite thought about it that actually you're reading it from the back to the front. So it's like you start at .com or .edu, then you get into the domain, and then within that domain, you figure out what type of a server it is. So for instance, when we do www, right, it means that we're in the Amazon domain and we are looking at the web server. When we have a NS, so it would be ns.amazon.com, we're in the amazon.com and we're looking at a specific domain name service and so on. So we'll see that in a second. So it starts with these, right? So you'll have either those biz.com.edu or you have the country code.us.jp. So DNS in Unix, bind9 components. It's got the resolver, which is essentially a subroutine library used by commands and user programs. So we will see we have commands like dig, etc., that are related to DNS, and you guys will be playing with those commands on the terminal. And then you have the daemon, which you guys know what a daemon is. The name server is a daemon is just a program that runs in the background. It's the name server. It's actually called named. And this service, is configured via a collection of ASCII files. This named is bind9, right? So this is what you guys will essentially have to configure this week, right? Zones, this is a term that might be confusing, but essentially this is like a collection within curly brackets of all of your IPs for your domain. All right, so you'll have to create these zones when you do the configuration, and essentially that, it's got a specific structure, but this is where you're going to put in the IPs to host names and vice versa. So name servers, DNS, provide name resolution services in the form of DNS zones. So zones, a zone is the name given to the collection of hosts within a domain. So you can see over there, you're going to have that. So edu.pnw.mail or edu.pnw.mx or edu.pnw.web, www. So that's mapped to the IP addresses. And it's going to be in a specific format. That's it. So it's not hard. What you have to be careful with is that you don't have a typo in there or something like that, because it'll break the program. But otherwise, it's pretty straightforward. You configure all of this. As you know, in the Unix way, everything is a file, right? So you configure everything as simple text files. All right, zones, as I said, map host names to IP addresses. Others define and so you'll have like the forward one and the reverse one. So you use these reverse zones also to define the reverse lookup. So it's the opposite query. You can see at the top is host name to IP address or IP address to host name. So you'll set two of them. That's essentially all it is. All right, so as I said, bind9, around 1984, in Unix, the master configuration file would be located in etcname.conf, right? So in the etc folder, you can go to the name.conf, and that's going to be your configuration file for bind. So make a note of that. These are the things that you will have to configure. By default, bind 9 is not configured on your CVMs, and so you'll have to designate one to be that. The syntax for some of these files looks like that. You can see the pound sign as a comment. You also have the / curly bracket, as in C style. Those are for comments. Then you'll have something called keyword, the arguments, and then in curly brackets, essentially, the lines of code that you need to specify. Okay, obviously you don't need to memorize this. Just be aware that this has a specific syntax, but the information will be provided for you. So here, for instance, you're just running a command, and then you're specifying that there's a cache where the information is stored. Okay, do you guys see that? So some of this, there will be I'll show you in the repo. I've provided a lot of files. And what I recommend when you configure bind is that you don't type directly the information into the files, but instead download the files from the GitHub, sorry, from the Brightspace, because you could make an error. So it's better to modify a little bit than to type everything from scratch. That will usually, I've noticed, that breaks. That will break. All right, so let's take a look at the process here of DNS. So you have a host machine, seed, the process of name resolution. You have your DNS client, which will say something like who is hamlet.com. That's going to be just a UDP packet that gets sent out with the DNS protocol. The steps here are going to be, number one, look at the local host's etc host file. So in DNS, you have multiple things that can do DNS resolution. In Linux, the very first file that does DNS resolution is the host's file. So that's really important. That's also the first problem that you have to solve in your homework assignment. So in etc/host, you will have DNS resolution entries. So for instance, if you look in there, localhost is mapped to 127.0.0.1 and so on. So one of the attacks that we will do will be to etc host. So for instance, there's an example. If you do cat on the terminal etc host, the file will show you localhost 127, and it would show you printer1 IP Canada, and so on. So it basically shows the resolution. Number two, the client can contact the DNS server. So you can see once it checks etc host on Linux, and you can specify that order also, but by default, it's going to be like that. So the client then goes to bind 9, and that's going to be why you need 2 servers. In fact, this lab really needs 3 VMs, but in essence, you could launch the attacks from the client as well. But you at minimum need the client and the server to do. DNS client. So the configuration is going to be different on both, right? So you have a client and a server. On DNS server, you will have to configure bind. On DNS client, you are going to have to tell the client that it needs to use a different DNS server. You guys know this already because you've taken many networking classes. All computers need some kind of a DNS server. That's provided automatically on your VMs. You kind of need to turn that off or change the address, I suppose, and tell it that instead of using the provided default DNS server, that you need to use your defined DNS server. So on the client side, one of the places for configuration will be etc resolve.conf. You can see that here. right? So etcresolve.conf. And in this example, you assume that you have DNS client over here, and then you assume that you have DNS server over here, combined. So then you're saying, okay, client should use, you use the keyword name server to indicate that client should use 192.168.1.4 as its DNS resolution. So then it'll look for that server, and that server should be configured to be a DNS server, such as with Bind. Does that make sense, guys? Is that clear? All right, Unix commands. These are, some of the Unix commands that we can try out on our machine. So, Unix commands on the terminal, you can do whois pnw.edu, right? And get some information about that. The name is the actual name of the daemon. So the name daemon listens on port 53 on UDP. All right, so that's something that we need to know. DNS uses UDP. It's listening on port 53. So on the bind server, you want to check for that. So on the bind machine, you can do etc bind name.conf and look at the configuration as well. So how can you find out if bind is running on your Linux machine? You can, you guys already know about pipe and everything. So you can run commands such as ps, which shows you the running processes, ax, and then you pipe that into grep name to see if the process is running. Okay, that's one approach. You can also do netstat, my favorite command, right? Netstat space -na pipe grep UDP to check if the port number is open. Does that make sense? So again, this is an abstract lab, right? You got to be careful when you run it, that you understand that you've disabled the normal DNS server, that you have enabled bind, that the client is using bind, because that's just getting set up, one of 4 problems, and then you actually have to do the 3 problems where you're going to be doing attacks on this infrastructure. All right, additional commands that we're going to want to try, etc initd bind 9 start stop restart. Every time you do a configuration, as you know, on one of the ASCII files, you probably want to restart the system. I don't remember if bind is installed on the CVMs as they're constantly being updated, but if it's not, sudo apt-get install bind 9. Okay, and that should get you bind 9 installed. You have also this file is where you can specify the order in which DNS resolution will happen on Linux. So do you want it to look at host files first? Do you want it to go to the bind server? Right, so you have etchost.conf specifies the order to DNS resolution. Any questions so far? Questions? We have the dig command. That's another one that you will be using. Basically, you can query DNS records for a domain name. So you can do in the terminal dig, moon.citg.pnw.edu, right? And then it's basically a facility to help you to make sure that your DNS server is up and running. If you run dig, addresses of the root servers should appear. Reverse lookup. So why would you need reverse lookup? Sometimes you get, just IP addresses and you want to know where it's coming from. Let's say somebody is attacking you, spamming you, whatever it is, from 58.9.62.229. And you want to know what the domain name is for that. Then you could try something like dig-x and then the IP address, and it'll provide information about the resolution. A lot of these problems you'll test to see if they work with dig. Okay, so just be aware of that. So that's going to be a tricky part there. All right, so here's the overall setup for the lab. As I said, 3 VMs would be actually right, but you can do it with just two if it takes too much memory. So client would be, it's a client server architecture on DNS. So you have a client machine and then you have a DNS server running something like bind. So the client server, is 192, let's say 192.168.9.134. The DNS server is 192.168.9.132. So whenever client wants to go somewhere, anywhere, it'll query DNS server. You guys see that via DNS? And then if DNS does not know, DNS server would reach out to other DNS servers. So it basically is seed, copy one of seed, copy two of seed. Yeah, so this requires you to configure a NAT network. So if you guys have been having issues with that, as I said, I finally did, I think, figured out my problem. It wasn't automatically populating the things, but definitely it has to be NAT network. And I had to like configure this stuff manually. So I'll discuss that at the end of class. I just didn't want that to consume all my time today. All right, but yeah, that's pretty important that we get this done. Right. So what's going to happen is the first problem is just configure bind. Make sure client can do its normal DNS functionality. Then after that, the 3 out of the 4 problems, the last 3 out of the 4 problems are attacks. All right, so you're going to have to the second one is super easy. It's just understanding that etc host has a lot of valuable information, and you're going to play with it. The other two are a little bit more difficult. In the second one, we're going to assume that the attacker knocks out DNS server. And so it's going to impersonate DNS server. So attacker would actually be responding to DNS queries. And then in the last problem, we're going to leave DNS server running, but we're going to do something called DNS cache poisoning. And again, the whole point of this is just to understand how these services work. I encourage you to have Wireshark open on a lot of these labs just so that you can see the packets as they are flowing. That might help you out in your understand. Does that make sense? Are there any questions so far? All right. So yeah, so this is the setup, okay, that you have to do for the lab this week. All right, I'm going to go ahead now. Oh, that's the last one. All right, so let's look at the other set of slides then. So I have another set of slides, which I think is this one. And then we'll start looking at the PDF. So this is a nicer looking one. There's a lot of information in here, even how to write some of these DNS attacks. With Scapy, I'm going to skip that part this semester. But yeah, DNS and attacks, as you can see. So this is what we're talking about, how DNS works, and then some of the attacks. There's a lot of attacks. We're not going to cover the last 2 ones. Those are things that you can do for the term project, for instance, if you want. But DNS cache poisoning attacks, we will look at that, at least in the local environment. So we'll talk about that. Same thing I said before. This is the hierarchical DNS data structure or domain hierarchy. As you can see, it starts at root. Then it goes into these, the extensions like .com, .net, .edu, .gov, and the country codes. Then it goes into the actual second level domains. So below root, we have top level domain, such as this. Okay. Zones, I already explained what zones are, but essentially you can create zones like example.com. Then from example.com, you have France.example.com, UK.example.com. You have USA.example.com. And you can even create another zone, just New York City index.example.com, right? So it's very flexible, and it's up to you. It really depends on how many servers you would have in there. If you think about it, it's really about that. What if you're doing gaming or something, you have, many servers. So you break it down into these areas. This is something that you guys will do on a very simple, but you'll see it's very straightforward. In a text file, you just say zone and list your IPs. Okay. These are the DNS root servers throughout the world. So as you can see, you have, A through M, and these are, you can see, PNW has its own DNS servers. Purdue, West Lafayette has its own servers. Chase.com has its own DNS servers. Everyone, right, can have DNS servers, but there's a set of root DNS servers, and you can see that they're located in, it's VeriSign, University of Southern California, which were some of the original universities that started the internet, Cogent, University of Maryland, NASA, the U.S. Department of Defense, U.S. Army Research Lab, ICON, and so on, right? So several fixed ones that are provided. Okay, these are really important ones. Throughout the world, right? DNS servers are essential, and if you take them down, you will really affect the internet for that area. This has been documented, for instance, when the Russia-Ukraine war started. So Ukraine asked ICON to revoke Russian domains and shut down DNS root servers, for instance. But ICANN would not revoke Russian internet domains because it would have, have a devastating effect. So this is pretty crucial, right? So it seems like a simple structure, but it's actually pretty crucial. But they have, they can be used almost as a weapon. All right. All right. So yeah, you can take a look at that link. I've talked about this. So the top level domains are .com, .net, and the country codes, US, France, etc. So that we know about. All right, the DNS query process is what I was saying. So in your example, you guys are only going to have the first two machines, the client and then the local DNS server. Obviously, you could have in the internet the root, and many other servers that provide DNS. Okay, but we're only going to explore how this communication works. The query process and the cache actually are the two things that we're going to explore and configuring bind. Same thing I kind of said already, some of the important files in Linux related to DNS. So etc host, really important. Store IP addresses for some host names before a machine contacts the local DNS servers. It first looks into this file for the IP address. etc resolve.conf provide information to the machine's DNS resolver about the IP address of the local DNS server. Okay. The IP address of the local DNS server provided by DHCP is also stored here. This is what I was saying, you guys will have this already in your VM because obviously you can reach the internet. So you're going to have to disable that and tell it to use your own bind9. So that might be one of the more challenging parts of the lab. All right, here is a zone. I kind of wrote it down with my notes. But you can look at one. So how local DNS servers get root servers IP. You can see you can at etc bind name.conf default zones. And you can see how the structure of some of these. Okay. As you can see, one important thing to note here is that there's a lot of strange characters and spaces. When you create the zones, don't type this up. Instead, download the files that I provided on Brightspace. Same thing. Here's an example of running a command. So you can see we have the pound sign here, which indicates that we're on the terminal. And then you do something like dig, the dig command, and then you can query things like that. and the information that you get back is something like that. Okay, so here, this information is related to that root server, but in your lab assignment, you'll be told that you need to get this, and you're going to need to look for that in the output that you get. If you do, then things are working. If not, something is wrong with your configuration. Does that make sense? That's essentially how you're going to be testing a lot of the things, okay? By running dig, and it should show, the information that you configured. Same here. Another example, using dig, you can see kind of the same idea for other servers. Dig again, looking at information. You can see here it's providing, in this example, the www.example.net and the IP address 93.184.216.34. Essentially, that is the resolution that do you guys understand? So it's kind of like that. Remember, at the end of the day, the domain name provides that. Okay. Lab setup for DNS Infrastructure Lab, which is the one that we're doing today. As I said, we're only going to do client and server. Let's skip that. Let's name servers. So that's a command. I mean, so these are other commands that you can do. We're not using Docker, so you can disregard this one. Right, so additional servers. Yeah, so this one I've already talked about, but it's kind of the same thing. Remember, you only have two machines, really. Yeah, so here we are. So imagine this is a network. There's no router. So it's just your NAT network, and you really have two machines, right? So the user, in this case, I guess 10.9.0.5, and then the local DNS server 10.9.0.53. But you could have an attacker. That'd be nice if you had three. It would make it more obvious, but because of memory, may not be able to. On local DNS server, etc bind name conf, and this is where you're going to set up some of the zones, and we'll see that in the PDF. Okay. Any questions? Right. So I'm just going through making sure I haven't missed any commands. This is more specific in the PDF, so we'll look at that. But that's what the zones look like. This is the structure of some of the files. This part, constructing DNS packets, I'm going to skip. So I'm not going to go over this one. Essentially, we're going to do the attacks with netwalks. So it's netwalks is, it's kind of we're constructing packets, but it's just through a program kind of. It has a GUI interface. You could also do the attacks via SCAPI. Okay, do you understand what I mean? You could also, just like we crafted packets, we spoofed packets with SCAPI. You could totally do it for this lab. I just didn't want to spend so much time on that. But this obviously these are SCAPI type commands. So constructing DNS header. So I'm just going to kind of like show you constructing DNS header using SCAPI. So you can see LSDNS, and it starts to show you all the flags in there or the variables. It tells you kind of the structure of a packet and how it would look for DNS. And then it shows you the different classes that you have available for constructing DNS records. And then, as you can see, send a DNS query. If you want to try this out, feel free to do it. It's not going to be required. As I said, the attacks, we can just do them via netwalks, but you can see it's a simple SCAPI all. We create a UDP header and everything, the IP header, and then we construct the packet, and obviously it needs to have some relevant information for DNS. Okay. And then you could use these for the attacks. Whoops. Look. Implement a simple DNS server. So you could do that too, like create in Python your own DNS server. You know, that's fun. But the class is really not about attacks. It's more about sysadmin. So the focus will be to configure bind. More implement a simple DNS server, more header information, and it gives you, all the fields, etc., that are required. And then the local DNS cache poisoning attack. So this is one of the last problem we'll do. So this just walks you through it if you were to craft it via Python. All right. So as I said, for fun, you can do this spoof DNS. Hey, I'll give you bonus points if you do it. How about that? But we're not going to take this approach, and instead we're going to do just using networks. That, the Kaminsky attack and all that, I'm not going to cover those. Does that make sense, guys? All right. Are there any questions? All right. There's a lot of slides here, so, you can see through many attacks and how to do them in Scapy. So pretty fun things. But all right, let's go ahead now. So I've done the two sets of slides. So we've done this one and this one. So let's take a look at now we are ready, I would say, for the assignment. So let's take a look. So I'm going to click on this one. And it says complete the attached DNS lab. That's going to be that PDF document. For it, complete the following. Part 1, configure the DNS server bind and the DNS client. So that one has nothing to do with attacks. It just has to do with, having a DNS client and configuring it to use a DNS server. Part 2, complete the problems as described during the lecture, which are problem 1, etc hosts. Problem 2, disable DNS server and have an attacker respond to the client's DNS query. Does that make sense? How would how would an attacker disable DNS server? Denial of service attack, right? So they would first do a DDoS on the DNS server, take it out of commission, and then put in an attacker that would be listening on the network for DNS queries, and it would impersonate the DNS server, right? Obviously, you don't have to do a denial of service on the DNS server, just turn it off. That's it. Problem 3 is going to be the DNS cache poisoning attack. And that the DNS server bind needs to be on, and you just need to poison the cache, as we will see what that means. All right, that's it. That's your lab assignment. So that's what you need to complete. I'm pretty sure I created a Word document with the same information, as students sometimes get confused. So again, same thing I just said, problem 1, problem 2, so everything is there. Okay, so you need to complete these. All right, so we've covered these two sets of slides. We've covered this one, and we've covered this Word doc. So that just leaves this file, and this file, okay? So these two files that you see here are the files that when you go through the PDF tutorial, I guess, it's going to tell you to modify some files. So instead of typing everything in those files as you see in the screenshot, my suggestion is download these files to your computer and just modify them. Does that make sense? Because when students have done this lab in the past, they always get something wrong in these files. They're very prone to error. Okay, so if I click on it, yeah. I'm not sure that they even open. Oh, it might open on WordPad. So let's take a look. See, it looks like this, and it seems like pretty straightforward, but actually just replace that file. As you can see, these are the zone related files. What's important here is that you have your domain for your example is going to be example.com. And really what's important is you're saying that the www server is 101. So you're assuming that you have something like 192.168.1.101. Do you see that? So .101 would be the WW. Then this assumes that you have 192.168.1.102, which would be this one, and this would be a mail.example.com. And then the last one assumes, ns.example.com. So this would be 192.168.0.10. Why is it done like that? If you notice, it's just the way that bind works. That IP address is in the name. If you look over here, it says 192.168.0. Now, this is actual networking stuff, right? So in the NAT network that we get in VirtualBox, we're getting something like 10.0.2, right? So then you need to change that to reflect whatever network you're getting. Does that make sense? So you're not going to have a 192.168. What some students have done in the past is they go in and change that network 10.0.2 to be 192.168. That's fine. But instead, what might be easier is leave the network as 10.0.2 and just change these values to reflect that. Is that clear for everyone? So common mistake that's hard to see. Okay, make a note of that. Anyway, so that's an important tricky part of the lab that's sometimes confusing. But anyway, these files you want to download and copy and then modify. The other one looks similar. It's this one. This is the reverse file. You can see this one says example, and you can see this one has what's relevant here is it's got the www server, right, for www.example.com. And so it's saying that's 192.168.0.101. If your network is 10.0.2, then you need to change this to be 10.0.2.101 because you're specifying that network ID, okay, of your virtual environment. Otherwise, you can create a NAT network with that 192. So I guess that would be another alternative. Here you have the mail server. So this implies mail.example.com, and you're telling it that it's this server on your network so that you can find it. NS, the name server. So this implies ns.example.com and the IP 192.168.0.1. Got it? Pretty important little details that if you don't get right, because that's the problem with this. If one thing, nothing works. So one thing is wrong. All right, the last file here is DNS local. This is actually your sort of tutorial. This is pretty well written, pretty well documented. It's one of the best tutorials. I wish I had a tutorial like this for Hadoop. I don't. Hadoop will be a much more challenging lab to do. But this one is very good. You just have to pay a lot of attention to everything that you're doing. So don't be distracted because it is one of those things that if something was wrong, at some point, nothing will work. All right. So you can see so I'm gonna make a note here. This lab covers a lot of DNS attacks. We're only gonna cover the ones that I mentioned. But essentially, I'll talk about this, but I just want to give you an overview of it first. Let me move this. All right, so I'm going to move that there. So we've got a lab overview, right? I'll go over that. We're going to have the lab tasks. So it gives you essentially what we've been talking about, the architecture. We got a NAT network there. So first step, configure the user machine. So that is DNS client. It should be the easiest part, but just read carefully through it. Essentially, you're going to tell it not to use the DHCP provided DNS servers and instead to use the DNS server that you're configuring, which is the bind server. Then once you've done the DNS client, then you would configure the second machine, which is the local DNS server. Okay. So the local DNS server is going to have bind, as you can see, everything we've said about it. And this is probably the most involved configuration. So you need to follow every step here that it says to the letter. Okay, it talks about the zones. You'll have to define these. As I said, the forward and reverse zone. Remember, make a note of the IP addresses and what they should be, network IDs. Then, as I said, it's going to tell you to set up these zone files. Notice that I've already provided these and recommended that you download them instead of type them up. It gives you the description of what everything means. And then once you finish, you're going to restart your bind server, and from the client, you're going to test it. You see what I'm saying? So you're gonna use dig to kind of make sure that everything works and everything is fine. Once you've completed that, then you're gonna move to part 2 of the lab, and it's the part that says attacks on DNS. So the attacks on DNS, you're going to is going to be the 3 things that I mentioned. So it's going to be task 4, right? This attack modifying the host file. This is the etc host. So you're going to do that one. Then task 5, directly spoofing response to the user. So this is the one where you would take down the DNS server and then have an attacker pretend to be a DNS server. And you're going to do all that. And here is the tool that I told you about. Instead of using Scapy to craft the packets and spoof them automatically, we're going to use a tool called Netwalks. You can see it right there. Netwalks is very nice. It's a network attacking tool. You just tell it what command, what type of an attack you're doing. So for instance, Netwalks 105 would be a sniff and send DNS answers. So, and we just specify some of the parameters. So I'll help out a little with this one. All right, these commands will help you to get them set up. But right now, I don't want to get into attacks or anything like that. Right now, your main goal is to get that bind server configured, right? That's the key. Don't take this lab as an cybersecurity or attacks lab, and instead think of it as a sysadmin lab. And what you want to do is configure bind correctly and understand how things work. And then the last attack that we'll do is the DNS cache poisoning attack, task number 6. So, as I said, this one, the DNS server bind is up and running, but we're just going to attack it. And then when a DNS client communicates with it, that's where we do something. And that's it. After that, targeting the authority section, all that, the rest you can skip. Make a note of that, right? You don't have to do the rest. Is this clear, guys? Any questions on this one? Got it? All right, great. All right, so the next thing we're going to do then, that's the documentation, right? This PDF is going to be your main document. So what we can do now is just start playing with the virtual machine. and then come back to this document also. So to do that, going to start the VM. You're going to need two VMs here. I don't know when this lab will be due. We'll just see on Thursday how you guys are doing with it and questions in general. I would say this one yeah, this one is probably one of the harder ones. Oh. All right, so let's go log into the machines. Fun things with these machines. Yeah, so I was reading about NAT and NAT network, and NAT works usually just for one VM in VirtualBox. So when you want to have multiple VMs, you have to use NAT network. And for some reason, it wasn't automatically providing things, but I was able to manually set the IPs. So we'll test that out in a sec. So I'm showing this because you may have this problem yourself, and I want to make sure that that this is not like a randomly sometimes it works and sometimes it doesn't. It's got to be consistent. So I looked at it yesterday. So let's take a look at this. All right, so I have one virtual machine, and I have another virtual machine, right? So they both need to have, so I'm going to network settings. See, I have NAT network. I even tried creating like a second NAT network as long as it matches. I have one NAT network, and I have another NAT network. See, they're both on NAT network. So then I have config. So it has to 10.0.2.15 here. And then I go to the other one. Terminal. I have config. This one has to 10.0.2.4 network. So I have the firewalls off right now. So send 10.02.15. So you can see I can reach it now, right? 10.02.15. That's from 10.024. So I need to go to 10.02.15, just this one, and ping 10.0.2. And as you can see, I can reach it now. Right, so this is the problem. It was really throwing me off last week. You can SSH into it also. Oh, it's actually big. Whoops. So I'm 10.0.2.15, so I want to SSH into 10.0.2.4. And you can see I'm there. So now if I do ifconfig here, I have 10.0.2.4. If I exit, I have 10.0. So I'm able to reach the key thing. So in summary, NAT network most definitely, configure them both. And then I had to literally go here, wired connected, wired settings. This needs to be enabled. I click on this little sprocket thingy. I have these settings here. I have identity, and I have IPv4, and you can see I literally, instead of using DHCP, I use manual, and I put in 10.0.2, the IP that I know they're on that network because it's the 10.0.2. So I did 10.0.2.15 for this one. The net mask is 255.255.255.0. And then the gateway for these I discovered is 10.0.2.2. And so just make sure that if you're having issues, try that for sure. So I did the exact same thing on the other machine, and I just called it 10.0.2.4. Does that make sense, guys? Any questions on this idea? If you're having issues, if it works automatically, great, but it needs to be on that network. Make sure you have the ping functionality, make sure you have SSH. And for this one, actually, you can turn off the firewall. There's no, this this DNS lab, I don't believe requires the firewall. So you can just turn it off for simplicity, set it to manual. If you have different MAC addresses here, I have a suspicion that I somehow have the same MAC address, and that may be the issue. So just make sure that you have different ones. Let me know if you have different ones and everything works fine, and I just didn't want to have to create another VM. Any questions, guys? All right, so we've got the machines going. So let's, this is what you need to have a DNS server and a DNS client. So now let's go in to, so now the PDF, right? So at this point, I'm done with the lecture for today. And let's instead start working on the lab, right? So this is a longer type of a lab. And so we want to start exploring it. So what do? So you're going to go to the local DNS lab attack PDF on Brightspace, and you're going to start reading through the information. So we have here, right? So, so we have DNS domain name system is the internet's phone book. It translates host names to IP addresses and vice versa. This translation is through DNS resolution, which happens behind the scenes. DNS attacks manipulate this resolution process in various ways with an intent to misdirect users to alternative destinations, which are often malicious. The objective of this lab is to understand how such attacks work. Students will first set up and configure a DNS server, and then they will try various DNS attacks on that target that is also within the lab environment. As I said, my point with this is don't think of this as learning the cybersecurity part of it. Instead, just trying to understand how DNS works, essentially. The difficulties of attacking local victims versus remote DNS servers are quite different. Yeah, so there are two labs. There's another one actually that you can find online for that, but this is a local DNS server. So this lab covers the following topics: DNS and how it works, right? So we've talked about it. Key goal here is DNS server setup. I want you guys to set up fine. And then essentially a few attacks such as cache poisoning. Packet sniffing and spoofing, SCAPI, and all of that we've already covered, right? So you guys have a sense so that we'll skip. All right. I believe there's a more updated version of this lab. It's kind of the same thing, but you can find a more recent at the Seat Labs website. All right, so the first thing, right? The first thing we want to do, your first objective is part one, setting up a local DNS server. Remember, that involves the two computers, DNS client and DNS server. All right. The main purpose of this lab is on the DNS attacks, and our attacking target is a local DNS server. Obviously, and you guys know this very well from ethical hacking and all that, obviously it is illegal to attack a real machine. So we need to set up our own DNS server to conduct the attack experiments. The lab environment needs 3 separate machines, one for the victim, one for the DNS server, and another for the attacker. Although, as I said, the attacker could be the client as well, so that you just have 2 machines, given that you're just sending out packets and you're doing this in the same local network. That's equivalent. Okay. So you'll just need to have 2. We will run these machines on the physical machine, obviously. All these VMs will run our pre-built seed VM. Figure 1 illustrates the setup of the environment. For the VM network setting, we are using so let's read this actually. For the VM network setting, if you are using VirtualBox, please use NAT network. So you'll need to use NAT network, which I just demonstrated, as the network adapter for each VM. And you guys are not using VMware, I think. For the sake of simplicity for this lab, as the goal is really just bind and all that, we put all these VMs on the same network, something like the 10.0.2 network. In the following sections, we assume that the user's machine IP address is 10.0.2.18. So make sure you make a note of what your client IP is and what your DNS server IP is. The DNS server's IP is 10.0.2.16 for this note. So just make a note of it. And the attacker's machine is 10.0.2.17. We need to configure the user machine and the local DNS server. For the attacker machine, the default setup in the VM should be sufficient. All right, so we have the machines here: user machine, attacker, local DNS server. Question so far? Makes sense, right? Okay. So we are ready now. So you can start if you'd like. Just, I would recommend grab a sheet of paper, draw 2 machines, put the IPs on them, say which one is client, which one is DNS server. That helps me. And then you would start the configuration of the virtual machines. So let's read through the first one. I mean, I'm literally, I've done this every year for many years, but I haven't memorized it yet, and I definitely have to pay attention to it. All right, so we want to configure the DNS client first. So on the user machine or client machine 10.0.2.18, we need to use 10.0.2.16 as the local DNS server. So the other machine needs to become the bind server. By default, the DNS server program is already running in seedVM. This is achieved by changing the resolver configuration file. So etcresolve.conf. So we need to remember that. of the user machine. So the server 10.0.2.16 is added as the first name server entry in the file. This server will be used as the primary DNS server. So that's what we want. Unfortunately, our provided VM uses DHCP. So if you're using DHCP, right, it's going to overwrite those name servers. So unfortunately, our provided VM uses DHCP to obtain network configuration parameters, such as IP address, local DNS server. DHCP clients will overwrite the etc resolve.conf file with the information provided by DHCP server. So what that means is that even if you go to that etc resolve.conf, and even if you add the name, the IP of the bind server, it will be overwritten in a few minutes by DHCP. And so things won't work. So that's what this means. So DHCP clients will overwrite the etc resolve.conf file with the information provided by the DHCP server. One way to get our information into etc resolve.conf without worrying about the DHCP is to add the following entry to the etc resolve.conf head file, right? So you have to do this. So you're gonna add the following entry to that file, name server 10.0.2.16. Now remember, this has got to be whatever your IP is for your designated bind server. Once you do that, you will run the following command for the change to take effect. Sudo resolveconf-u. Okay, as you can see. The content of the head file will be appended to the dynamically generated resolver configuration file. Normally, this is just a comment line. The comment in etc resolve.conf comes from this head file, essentially. After you finish configuring the user machine, use the dig command to get an IP address from a host name of your choice. From the response, please provide evidence to show that the response is indeed from your name server. If you cannot find evidence, your setup is not successful. Do you guys understand this question? So it basically says, once you've configured your DNS client correctly, and you do this, you use the dig command, it should say, my name server is 10.0.2.15. Got it? So it's saying, so even if bind is not configured correctly, it knows to query bind, your bind locally. So you've successfully done it. So as I said, this lab is not super hard, but it's got these little abstract and subtle things to check if things work or not. Okay? Any questions? All right, so let's take a look at it. So I'll start with that. So I have two virtual machines, right? 10.0.2.4. So I am going to designate just, I'm going to say that, let's see, IF config. I'm going to say that 10.0.2.4 is my DNS client. So then I'm going to designate 10.0.2.15 as my DNS server. Okay, so I'm going to do clear here. IF config. So 10.0.2.15 is going to be my DNS server. So I'm going to configure bind here, and I'm going to configure DNS client on the other one. So now I'm going to go to the other one, and I'm just going to follow the instructions. And that's it. I'm going to follow the PDF. So let's go back to the PDF right here. First thing it says is go into etcresolve.conf. So I'm going to go there. etc resolve.conf, right? Just like that. All right, so you can see, what do you guys see? It says actually, because this is my computer that I use every semester, it's already configured. Name server is 10.02.15. You guys probably don't have this yet, as you haven't done the thing with the head setting. Does that make sense? So now you have to configure that. So I'm going to do Control X, right? I'm going to go back to PDF. So I've done etcresolve.conf. So one way to get our information into etcresolve.conf without worrying about the DHCP is to add the following entry into etc. So let's go to this file, right? So we want to navigate to etc resolve.conf. etc resolve.conf. Right, so cd etc. I actually don't want to just now you need sudo privileges, correct? So sudo nano etc resolve conf. All right. Then what was it? Resolve d something like that. Resolve.conf.d. Resolve.conf.d. And then head, I believe. So sudo nano that file, you can see there. Then in this file, this head section, I added name server 10.02.15. You guys probably don't have anything there, I would imagine, but you need to add the entry of whatever is going to be your bind9 server. Are there any questions? Making sense? All right, so do this. I've shown you how to do that. Now we look at the PDF document, and it says that you have to run the command sudo resolve conf -u. So sudo resolve conf -u. My battery's. Oh no, I didn't bring my thing. All right, well, I have one in my office. Should make it. All right. So any questions, guys? So we have to do sudo resolve conf -u. Conf.u, and that's it. So if you run that command now on DNS client, and then you go to your resolve conf, hit enter, you'll see that you have that entry 10.0.215. Do you guys see that for DNS client? All right, I'm going to run to my office to get my other power cord. I'll be right back. So just keep working on the lab.